Next, we have to find the coordination number. Coordination numbers are the number of nearest neighbors to a particular atom. Suppose we consider a simple cubic structure in which atoms are at only the corner of the cubic unit cell. So consider this is the one of the atom, and now we have to find the number of atoms which is very close to this atom. If we extend the structure of the lattice using the unit cells, we will have a structure like this. Similarly, if we extend on the left hand side, again we will have this type of the structure. So this is one of the atom. Now we have to find the nearest neighbor, because nearest distance in a simple cubic unit cell is the A, that is the length of the side, because the atoms may be on the distance at A on a side, or at a distance A root 2 on face diagonal, or at the edge of the body diagonal, which is at a distance A root 3. This is A root 2. Face diagonal is A root 2. So shorter distance is A, which is the side. Therefore, we will consider the number of atoms which are very nearer to the given atom. So one of the atom is marked with red, another is this second, third, fourth, and one of the atom is in the back of this face, is in the backward of the plane of diagram. Similarly, one atom will also above this plane. The coordination number for simple cubic will be 6. Similarly, if we take the body centered, in body centered, atoms are at the corners of the unit cell, as well as one atom is at the body center. Body center means the atom is at body diagonals, at the center of the body diagonal, and this distance of the body center from the any of the vertex is A root 3 by 2, and this is the shortest distance between any two atoms. Therefore, to this particular atom which is at the body of the unit cell, total 8 atoms are in the nearest. So number of the nearest neighbors, or we can say coordination number for the body centered cubic unit cell will be 8. 4 in the lower side and 4 on the above side. Now we have to find the nearest neighbor for the face centered cubic unit cells. In face centered cubic unit cells, atoms are at the corners and also at the center of face. This is the center of the face. So this distance is A root 2 by 2, and this distance is the shortest distance. So we have to find the number of the nearest neighbors, or the number of the nearest atoms which are at a distance A root 2 by 2 from this particular atom. For this, we can find the nearest neighbor using the alternate method. That is, if we take atom, then in close proximity we can make 6 atoms or spheres which are close packed. And similarly, in the second layer, the voids which are above can be covered by the 3 spheres. Similarly, 3 spheres will be in downward direction. So total to a particular atom there will be 6 in first layer, 3 in upper layer plus 3 in lower layer. That means total 12 atoms will be the nearest neighbor. So in FCC, coordination number will be 12. Therefore, we have to remember that for simple cubic, nearest neighbors are 6, body centered cubic, these are 8, and face centered cubic, these are 12. Now we have to find the density of the unit cell. Density of the unit cell is equal to the mass of unit cell by volume of unit cell, because we know the formula that density equal to mass per volume. So if we are finding the density of the unit cell, we have to take the mass of the unit cell and the volume of the unit cell. To find the mass of unit cell, we have to check how many number of the atoms in the unit cell. So suppose this is Z. Z are the number of atoms in a unit cell. If it is a simple cubic, then Z will be 1. If it is body centered cubic, Z will be 2. And it is FCC or face centered, then Z will be 4. We have already told that Z equal to 1 is calculated as number of the atoms, and one atom is shared by the 8 unit cells. In body centered cubic, 8 atoms at the corners shared by 8 unit cells plus 1 at the body center is shared by the 1 unit cell itself. And in FCC, 8 corners shared by 8 atoms or 8 unit cells plus there are the 6 faces, and 1 face is shared by 2 unit cells. So in this way we have to calculate the number of atoms per unit cell. And then we multiply this with the mass of the atom. M is the mass of atom. If M is the molar mass, that is mass of the 1 mole, which contains Na number of the particles, that is atoms. Na is the Avogadro number. This is equal to 6.023 into 10 to the power 23. So we can write M equal to M by Na. That means mass of the 1 mole divided by the number of particles in the 1 mole gives the mass of the atom itself. This is divided by the volume of the unit cell, and unit cell we have taken cubic unit cell, and this cubic unit cell has the side A, so volume will be A cube. So we can write it is Z into M is the molar mass, small m represents the mass of the atom, and capital M represents the molar mass, divided by A cube into Na. Na is the Avogadro number having the value 6.023 into 10 to the power 23. So using this formula, we can calculate the density of the unit cell. Now we will calculate some numerical problems.